Good morning, everyone. I think we can start here. I think we're past the allotted time, start time. So my name is Gary Tomchuk, and I'm with the software-defined infrastructure team, part of our worldwide systems storage team. And my role is really around business development and sales for solutions such as the AI and the analytics solutions for Spectrum, for IBM storage software, essentially. And presenting with me today, too, is Benoit Grenier. He is our IBM File and Object Systems technical manager across Europe. And what we want to talk about today really is about how do you make your infrastructure more effective, more efficient, and do it through optimizing your data pipeline. So we'll talk a little bit about the. We'll start by talking about the data management challenges that everyone in this industry is facing, that you're likely facing. Then we'll talk about the AI data pipeline a little bit, and then we'll take that and we'll talk to it in the sense of through the eyes of IBM storage, or what that data pipeline looks like. And then we'll talk about some Spectrum storage offerings that actually plug in to this AI data pipeline. It kind of makes it real. We'll talk about data unification. So basically using, going back to Hortonworks terms, HDP with Spectrum Scale and how that kind of works together. Go through a few case studies where we've actually made this happen. And then we'll talk about something that's fairly new at IBM that you may or may not have heard, but there's a new offering in general called IBM Spectrum Storage for AI. And then we have multiple offerings underneath that name, essentially. So, data management challenges. So, we hear this in every presentation, right? That, oh, there's so much data. Data is ubiquitous right now. But it is, it is a fact. And what we show here is that the number of firms that grew to over a petabyte in data grew by a factor of 3, or 3x, 3 times, between 2016 and 2017. So it's starting to be, that date's getting a little bit old now, or this number's getting a little bit old, but it serves the point of that firms are getting a lot of data on their hands. And 39% of firms in general see this sourcing and gathering, managing data, basically data management, right, as the biggest issue that they're facing. When they're trying to get to value in terms of insight on their data. So, what are those challenges that they're facing? The first is the silos, right? You have silos of storage, perhaps. You may have a line of business. You may have a departmental, system and storage. You may have, companies that you've acquired and then their own infrastructure. And so you start having these pockets or these silos of infrastructure. And then you start getting multiple copies of the same data, right? You're copying, somebody needs the data, let's move it over here, and let's do some analytics on it. And that leads to, third point there, which is you start doing analytics on stale data, which is pretty useless, really. You're going to get insight on something that doesn't exist anymore. You may, or they may, be facing a very time-consuming ingest cycle. It just takes so long to get that data into the system. And then, both on the compute side and the storage side, you get into this term that we call cluster sprawl, right? So you have data, you want to grow that, and it grows independently, and so on and so forth, and you just end up with a lot of clusters. So, in this world, today's world of these new generation applications, like Spark, like Hadoop, like TensorFlow, they use infrastructure now which is very hungry. A lot of GPUs, like NVIDIA, for example. Even our power servers have NVIDIA GPUs embedded in them, and what you really need is a data pipeline that can support that processing power. Okay? And you need that from the sense of when you're first starting out to, when you go into production, from a small startup infrastructure size to a very large size. So that's what basically what you're looking at. Now we have something called this is our general version of our AI data pipeline or AI data workflow, and so it goes through those stages of ingest, right? Ingest data, which can be a timely process. Then you go into this classify, sometimes known as prep stage, the preparation stage, which is also very time consuming, as it says up there too. Like 80% of the time in this pipeline is spent in that segment right there, the classify. And then we have the training stage, where resource optimization becomes a real issue, both on the compute and the storage side. And you get into inference. So that could be a matter of, and you may have heard these terms before, of the challenger and the champion model, where you may have a model that's running efficiently. The challenger model comes out of the training stage, and it challenges that champion, and then that becomes the new champion, and on it goes. And I think IDC, has a nice definition of kind of what you're trying to get to. So look for dynamically adaptable, simple, flexible, secure, cost-efficient, elastic, that can support this high capacity, high throughput, low latency. So I guess everything. Those are all the things that you would be looking for in a good workflow. And then what you're trying to get to is, if you can move to the right-hand side, the business value, you're trying to get faster time to insight, right? That's the goal, the ultimate goal. You're trying to improve your model quality consistently. You're trying to lower your CapEx, your OpEx. You need to be agile. You need a system that allows you to have that agility to do what you need to do. And it's to improve the client experience. So it's all pretty, nothing earth-shattering in terms of what you're trying to get to, but you just need that pipeline to be able to do that for you. So what we did, we took the AI data workflow I just showed you, and we kind of, from a storage perspective, a spectrum storage perspective, what we did is we broke it out a little bit further, okay? A little more granular. So we have these, we still have ingest as ingest. We can't really change ingest, and then we identified a new subject of, we took the the transform, and we added classify to it. So it becomes a classify/transform, like the prep stage. And then we moved to, we took the training stage and called it, an analyze/train. And this will make sense in a moment as to why we did this. And then we have our insights. So we took this and we added characteristics to each of these pillars, essentially. So not that every firm, every enterprise would do each one of these things, but tries to capture, based on case studies that we've looked at, what are people really doing when it comes to ingest? Well, some of the things they're doing is, global ingest, right? You give a global company, needs to ingest data from all different places. How do you do that? What's underlying to make that happen? You may need fast ingest to do real-time analytics. So same thing. And under each of these categories here, we actually have what would be needed. So under fast ingest, we have, you would need a high throughput it'd be a high performance tier. On the global side, it would be, again, throughput oriented, but globally accessible. Perhaps and likely a capacity tier, right? And then we put the transient storage in there as well, which is a term that we've seen pop up in a few places, which just means bulk data coming in and being stored. And if that's the case too, it's just, again, throughput oriented. It's a temporary landing zone, likely software defined. So again, we did the same thing with classify and transform, because part of the transforming piece, getting that data ready to be used. Again, remember that's the part that's 80% of the time. Within the data flow. A lot of it's classification. So we've added a term of classification and metadata tagging. So that needs to be a high volume index-based auto tagging function. And then your usual ETL process. And so, you can see for each of these, I won't sit there and read the whole thing to you, but through all the stages, we do have those characteristics of what is really going on. So then what we did is we took the products, the IBM offerings that we have, and that's the great thing about IBM and IBM storage right now, is that because of the breadth of our portfolio in storage, from flash all the way to tape, it fits very nicely into this AI data pipeline. So 4 products that we're talking about here, and the underlying unifying type offering here is Spectrum Scale. We'll talk more about Spectrum Scale in a moment. But we also have IBM Object Store, Cloud Object Store, it's called. We have IBM Spectrum Discover, which is a brand new product that we have. And we have IBM Spectrum Archive. So you can kind of see where those products all fit. And the point is, like fast ingest, we have something called an ESS, which is, I'll talk about in a moment, which is our Elastic Storage Server, which is basically our offering for Spectrum Scale, with Spectrum Scale. But we have different models that fit in here too. So in this case, you'd want to plug in a flash version of our ESS as something that's very, very fast, right? Throughput oriented. However, you move all the way to the other side to maybe the archive piece of this model training, which occurs, and we again have an ESS, or Elastic Storage Server, right? The difference is that this is a capacity-based version. So, more spinning disk, more capacity in general, not a lot of flash drives. So again, that's the point, is that we, because of the breadth of our portfolio, we can plug into all these different characteristics within each of these pipeline stages. So what are those products? I'm not going to go too deep on the products themselves, what they all are, but just to give you an idea of what they are. So IBM Spectrum Scale, that's our high-performance file system, scale-out file system. And really what it does, it delivers data management for enterprises that are swamped with data, have that data management challenge of just too much data. And it does let you to grow the infrastructure while allowing you to start small and grow as your enterprise grows. So just showing, it's a different way here. Really what it allows for is high performance and scalability, which is needed in any data pipeline. Half the firms out there, half the companies or the enterprises out there that are delivering the top spec SFS benchmarks are using Spectrum Scale. It does support file systems, large file systems up to tens of petabytes of data, billions of files, all within a cluster. It has built-in smart policy engines, so it allows the movement, the policy-based movement of data from flash, to the different tiers, from flash to disk to cloud to tape, as needed, as the data goes through the data life cycle. It's enterprise ready, enterprise class. You'll never find anything that's better in terms of being ready for enterprise, in terms of disaster recovery, encryption, or erasure coding. And it's flexible. You can use it in a hybrid type cloud, for example. So, and you can use it in a shared nothing, a shared storage, and we'll talk about that in a moment as it pertains to Hadoop and how that works, how it fits in well. Spectrum Scale. Is that a new term for people? Generally, when I say Spectrum Scale, kind of a new term. Okay. Spectrum Scale has been around for a long time. It's been around since 1993. It's been out. It was rebranded after 1 year, in 1994, to GPFS. And the point is, and it was rebranded about 4 years ago to IBM Spectrum Scale, and we have a whole IBM Spectrum suite of products. But it's being used at over 4,000 clients worldwide right now. And it really started being used in the high-performance computing world. And what we've done, as we take some of that technology and those concepts into the business world and analytics and AI, we start seeing it used now for workloads like Hadoop and Spark, and also used in SaaS grids, SAP HANA. We're doing a lot with Spectrum Scale now in the AI world in general. Actually, we're doing a lot of stuff right now in autonomous driving as it pertains to Spectrum Scale and our storage. And you see it at places like the National Center of Atmospheric Research, for example, where they have it's like 28 petabytes, 16 petabytes online, 18 petabytes in archive, and again, the underlying system is, or underlying file system is Spectrum Scale. We have Red Bull Racing, so like you heard this morning, right, in the opening presentation this morning about Grand Prix racing and how data is being collected and those fancy steering wheels and stuff like that. And it is really neat stuff. But underlying all that to make it happen, to make those real-time in-race decisions, the underlying system or underlying file system there is Spectrum Scale. And so you see it in different places. You see it in terms of being highly performant with Citibank, where when they moved to our shared storage solution, ESS based, they improved their performance 100 times, not 100%, but 100 times. So that's pretty good. I think it's pretty good. And if you're wondering if we can scale, how big can we scale? We can scale to the biggest computers, supercomputers in the world. So, and we're actually the file system now for the Summit system, which is at the Oak Ridge National Laboratory. 4,600 nodes. And what I thought was kind of neat here, I did the math on it the other day because I was interested, but that's with 6 NVIDIA Tesla chips or processors, that's 27,000 GPUs. I just can't imagine the power that would take. But the point is that it's got very fast throughput using they use our ESSs as well. And then we're on the number 2 computer too in the Lawrence Livermore National Laboratory with Sierra. So big, huge systems. Underlying system is Spectrum Scale. The ESS. So ESS is simply our building block solution with storage and servers built in, but it's basically the way of easily building out your Spectrum Scale environment. So yeah, as I said, optimal building blocks for building out that scalable, reliable enterprise system of storage. Skipping down, the big thing here, well, there's a couple of interesting things, but the ready for business critical data piece, I mean, that's the other thing you get with the ESS is that with its scale RAID protection, that's the erasure coding protection, you get 5 nines of availability. So again, highly supporting business continuity. This is the family portrait, and I only show it for one reason, and that's just to show you that we have the different models. So I showed you before on the AI data flow where we had speed, right? The performance models, and then we had capacity models. Well, there's our speed models. We have a set of speed models. We have a set of capacity models of ESS configurations. And then we also have something called in the middle there, where it says 38 and 40 gigabytes on the bottom. Those are hybrid models, so they're kind of the best of both worlds, or something in the middle, I guess. It's the best way to explain it in terms of having performance and capacity. So again, those all plug into different places in that AI data pipeline depending on what is going on. We also have IBM Cloud Object Storage, and so truly that's your file storage, which can suck in data from almost anything. It can be your backup files, your archive files, your data oceans, so all your analytic databases essentially. Any IoT stuff, any industry-specific data. I mean, I guess it's almost anything, right? So if you need low-cost cloud-based object storage, this is what this is. Let me just skip through that. And it's, again, highly critically acclaimed. So, Gartner rates us 1 for analytics, archiving, backup, and cloud storage. So that's not too bad. And then we have these other leadership categories or designations from Gartner and from IDC, from CRN and TechTarget. So again, just to show you that it is a very popular, high quality, useful offering. We have Spectrum Discover. So if you're trying to figure out what that data is as it goes through the pipeline, so I said again we have ingest, right, and then we have Discover, and we have the classify stage, and this is where Discover would come in. And so it does this, it does a lot of things for us, but one of those things is this automatic cataloging of data, of metadata as it's created. It allows you to also tag some of the metadata, add more to that metadata so it can make it more useful by to administrators, for example, if they're trying to figure out what the data is and where it should be, and then from that data you could also tell when it should be moved to different storage tiers. So that's a fairly new product that we have. Data unification. So this is something we started doing last year with Hortonworks. So the question comes out as to why Spectrum Scale? Why do we do stuff with Spectrum Scale for analytics and AI? And the big well, there's 5 reasons here, and one reason is performance. It's fast. We support up to 40 gigabytes per second, and up to 300 terabytes in a 2U form factor. Very small, and it does scale linear. Up to, in this case, if you had 3, it'd be 3 times 40, 120 gigabytes in a 6U form factor. We, especially when you're using our ESS product, we reduce that data center footprint. And we like to deem this solution scale with Hortonworks, or I should be saying Cloudera now, right? We support, we like to call it as the best in-place analytics engine out there. And we do that, one of the things that makes that happen is that we have multi-protocol support, so NFS, SMB, POSIX, Object, HDFS, and so on. So the bottom line is that we don't need to have maintain separate copies of the data. Getting away from that that data management problem we talked about of having to copy data, the time it takes to copy the data, having 2 sets of data, which one's the truth, so on and so forth. That's what you want to get away from. Here we do the analytics of where the data sits in place based on the fact that we can read, utilize any protocol. And actually having the POSIX support is a very unique feature that we have in Spectrum Scale. We are extremely scalable, again, to billions of files. Again, think back to those supercomputers. So, the reason we can do that is because we actually have the data and the metadata nodes are not the bottlenecks in this system, like in others. Flexible architectures. You can actually install this on your various compute nodes with their own shared nothing storage, or you can utilize shared storage through an ESS offering. And data cycle life management. So really, like I mentioned this before, we have the built-in policies that you can modify, set up to move your data through the various stages based on where it is in the data pipeline. So, to make it kind of resonate more as to where things really fit, where Spectrum Scale fits. Here you've seen this chart, I'm sure, a number of times at different Hortonworks events. But what it is, you see the HDFS Hadoop file system. I wish I had a pointer on this thing, but I don't. I don't think I do. Anyway, what happens here is that we take IBM Spectrum Scale, and it becomes the storage layer in this HDP environment, okay? And then what we have is something called an HDFS Scale Transparency Connector, which kind of bolts on top. And allows all your tools and data access frameworks and applications to access your data through this connector through Spectrum Scale. So that's how it's implemented. Oh, and I just threw this in here too. I mean, if you ever want to see more on how all this works, and this will be in the deck that you'll have access to, there is a Red Book out there. And if you don't know what a Red Book is, an IBM Red Book, they're wonderful tools. They're basically, it's real people sitting down using our stuff and writing about the stuff and what they've learned. And this Red Book is actually a very good one, very useful, very readable. So, in your standard out-of-the-box, HDP, HDFS type solution, this is what you'd be looking at, right? A shared nothing model on storage-rich servers. Pretty basic. But we feel that that's very inefficient. It's very inflexible. It lacks enterprise features. It's not very. It has high operational expenses because of having to have lots of servers. You need more storage. Oh, let's add another server, and so on, and so on, and so on. So, what we're finding more clients are going to is the shared storage configuration, essentially. And what that is basically just allowing you to have, thin nodes. So your compute servers are very thin, very little disk on them, very little storage. And all your storage basically is done with this shared device, an ESS. So what does that allow for? Again, it allows for you to have these thin worker nodes, like I mentioned, with fewer disks on them. But it really, the real benefit comes from the fact that you can disassociate your storage with your compute. So you find your storage is growing very rapidly, you're adding storage to your ESS in that shared environment. Pretty simple. So again, that's a great feature if you're trying to avoid this cluster sprawl. So, all right. Should have been in that presentation. So just some use cases. So this is us thinking about how is this being used in the real world? Okay. One place it's being used, we find it's being used, is in EDW optimization, and it's being used in such a fashion where we're taking, basically, we're offloading the EDW, offloading that data to an ESS. In this case here, we do have the streaming ingest going into a fast-based ESS. We have data being offloaded to the EDW to an ESS. That's a capacity-based ESS, right? And it just allows your, EDW is a little bit more expensive. It just allows it to be more efficient and, better economics. We did have a company here in Europe that actually went this route, a large bank. Using our power systems, using Hortonworks, HDP, using IBM Spectrum Scale, using ESSs. So they went with 96 power servers, plus 3 AC 922s, and then a bunch of ESSs. And these were all performance models, four of one type, or 2 of one type and 2 of the other type of ESSs. And so, what they needed to do is they needed to improve their client experience. Provide new services to their clients, and they, like I said, through the use of data science and AI techniques, and they have implemented this, and it has worked so far very, very well. We have the ability to do unified analytics workflows. So, you don't have to just use this with your Hadoop-based files or solution. But you can use it with your other analytic platforms as well. In this case here, we're doing ingest through our POSIX capabilities, fast ingest into our fast ESS built for speed. And again, we can support the other analytic platforms in the Hadoop platform through the HDFS or POSIX interfaces into this, again, the Spectrum Scale-based, one file system, across all the ESSs in that one file system. And we're doing this as well. So this is a client in South Africa. And actually, I just visited them a little while ago to see how it was going. they absolutely love the solution of using ESS. I mean, they put a term, they gave it a term, and I can't remember exactly what the term was, but it was basically around, it was just nirvana for them, like just a wonderful solution, which of course I was happy to hear. But again, they're using, in this case, again, this is power as well with a couple performance ESSs in place. And they're using it for the predictive analytics capabilities with it, why they have it. And the third use case, we find this one kind of popular too, is in that we have a lot of existing, I mentioned before the technology, right? It's coming out of the high performance computing world, the technical world. And so you see a lot of these HPC clusters that are all standing up today with lots of data. In the example here is NASA. NASA, as you would expect, would have a lot of technical data that's being used for research in their high-performance computing cluster. So again, what it basically allows, again, through the POSIX interfaces, through the what we call a protocol node, through the HDFS transparency connector, again, access to that same data, whether it was technical data or we want to do analytics on that technical data or new data that's been ingested. I mean, you have that capability. And I guess one thing I just want to make clear that it's all available under one namespace of, that's the big factor of Spectrum Scale. It allows for one namespace across all your files. So all those files are viewable from everywhere in the system. So one thing I said I also mentioned here is that we just announced IBM Spectrum Storage for AI. And really, it's just a bunch of solutions that are coming out now to help maximize the Spectrum Storage AI story. And so we have a number of solutions out there. One of them is, of course, around power, our own product, called IBM Spectrum Storage for AI with power systems. We also have, and recently announced too, IBM Spectrum Storage for AI with NVIDIA DGX. That is very interesting when we're looking at the world of autonomous driving, for example. That's a very good fit for our solution with NVIDIA. And of course, kind of what we're talking about here a little bit today is the Hadoop Spark workload. Our what was called IBM Spectrum Storage for Hadoop solutions with Hortonworks is now being Cloudera. And as I mentioned earlier too, is that we have a lot of work going on with in the autonomous driving world. Again, just because our product set matches nicely to what they're doing, because you've got to remember they have huge amounts of data. From the test vehicles coming in each day that's captured into what I was calling before that transient storage area in some cases. And, we have that portfolio, whether it's the capacity or the speed to do what you need to do with that data. And just to sum up, this is what comes out of Forbes. As I say, IBM Spectrum Scale for AI is differentiated from both NetApp and Pure Storage offerings, and we provide the level of scalability that's nearly unmatched by anybody else in the industry. Hence, the ability for our product set, IBM Spectrum Storage, for AI to seamlessly integrate with the rest of our Spectrum Storage suite should make IBM's solution an easy one for enterprise buyers. So, this is just a third-party Forbes, validation of what we're trying to offer when it comes to the AI data pipeline. I like to think it's true. So with that, 3 minutes early. Any questions that we can answer? I say we, Benoit as well. Yes, sir.
What's the difference between Spectrum Scale Discovery and Store IQ?
And Store IQ?
Yeah, is it the same type of capability, or is it?
Do you know, Benoit? Store IQ, I'm not sure what the...
So you have a site repository on which you store all the metadata, millions available for file and object with IBM Spectrum Scale Storage, and this will be also available with IBM. So this means that we are opening this metadata management solution to non-IBM storage technology. But they need to be defined for object.
Any other questions? Okay, I think that's it. So thank you very much for your time. We'll have a booth out there if you want to actually see this and talk about it in more detail as to what we're doing. So otherwise, have a good show.